FEI presents Apreo, the best value, most versatile high-performance scanning electron microscope. As researchers and scientists demand more performance from their instrumentation while keeping an eye on their budgets, Apreo delivers. And that performance begins with resolution. Apreo shows an impressive 1.0 nanometers at 1 kilovolt. This is without the use of beam deceleration, which means this value is also achieved on samples that are tilted or highly topographic. A novel final lens design is responsible for the outstanding resolution. It combines an electrostatic lens with a magnetic immersion lens to create compound lens action. But resolution is not all. Contrast is the other crucial performance indicator, as we want to be able to distinguish small features in different materials. Apreo boasts the best backscatter contrast in practical applications, as you can see when we switch on the beam. Topographic contrast and materials contrast are available from the start, so you can use both even when simply navigating. When the sample is very sensitive and we are forced to use picoamp currents, the backscatter images still show good contrast. At these currents, any other SEM will struggle. The contrast performance is due to the unique in-lens backscatter detector that is positioned at the very bottom of the column. Here, it captures the maximum amount of backscatter signal, independent of the working condition. That is how Apreo shows backscatter contrast, even on the most sensitive samples. The other segmented detectors in Apreo can be read out and combined at will. This gives you only the sample information you need, whether it is topography or compositional contrast, something in between, or all of it in parallel. All this resolution and detection capability is available on a large range of samples, including magnetic samples. The buildup of charge on non-conductive samples often prevents researchers from making good images. However, several strategies are available to mitigate charging on Apreo. First, Apreo performs excellently at low beam energy and low beam current, as we have seen previously. But there is more. Smart scanning minimizes implanted charge, and charge filtering improves the situation on the detector side of things. With Apreo's new compound lens, the charge filtering capabilities have further improved, as seen on this polymer example, where the beam properties remain the same, and only detector charge filtering is applied. Finally, if we want to use a bit more beam energy or current, we can work in low vacuum. One case where beam currents are typically higher is analytics, acquisition of X-ray or diffraction data, EDS or EBSD. With 3 EDS ports available, 2 of which are 180 degrees apart, the Apreo chamber is well suited to accommodate this analytical equipment. The low vacuum mode is compatible with the use of analytical techniques, which means that EDS on uncoated insulators is possible. As in this example acquired at 300 Pascal, Apreo's vacuum range up to 500 Pascal and its maximum beam current of 400 nanoamps will never be limiting. Apreo makes all these different features easy to use. It's a snap to load and find your sample with photo-based point-and-click navigation. User guidance is a help feature that interacts with the UI. And the UI is full of nice little features, such as undo, which makes your life easier by allowing you to focus on your work instead of the instrument. All in all, Apreo brings you a wealth of features that give you all the answers with the least amount of effort. It is truly the most versatile SEM.